Assalamu alaikum. Good afternoon, dear students of Standard 11. How are you all? Hope you all are fine at your home in this pandemic situation. I'm also fine. So today, welcome back to my physics class. Dear students, today I will explain some topics from thermodynamics, and those are second law of thermodynamics, heat engine, and Carnot cycle. So let's start the class. At first, I will explain second law of thermodynamics. I will explain some statement of different scientists, physicists. Dear students, out of different energies, the speciality of heat energy is what? Do you know? All other energy can be converted into heat energy very easily, but heat energy cannot be converted into other energy easily. To convert heat energy into any other energy, a device is required. This device is called heat engine. Depending on the experimental experiences, scientists named Carnot, Planck, Kelvin, Clausius, after various experiments, formulated the second law of thermodynamics. Different scientists have stated the law in different ways. So let's see what they think. Kelvin Planck statement at first. It is impossible for a heat engine to produce a network in a complete cycle if it exchanges heat only with bodies at a single fixed temperature. Clausius statement. It is impossible to construct a device operating in a cycle that can transfer heat from a colder body to warmer without consuming any work. Carnot statement. No engine can be built which can extract a fixed amount of heat and will convert totally into work. From the first law of thermodynamics, we came to know that transformation among different types of energy is possible. If any amount of energy is abolished, then same amount of energy must evolve. That is, there is no destruction of energy. That means first law of thermodynamics supports conservation of energy. But the first law of thermodynamics cannot tell us which system will gain heat or which system will lose heat. Such as if we keep a piece of 1 kg ice outside, then heat will come from the environment and convert the ice into water. But if we keep this water outside, then it cannot be converted into ice spontaneously. From the first law of thermodynamics, we know that the amount of heat lost by a body or a system is exactly equal to the gain of heat by the other system. But the first law cannot tell us which system will gain heat or which system will lose it. To know the direction of flow of heat, we have to know the temperature of the two systems. Heat always naturally flows from high temperature body to the low temperature body. The reverse cannot be happened spontaneously. Even though the amount of heat of the colder system is more than the hotter system, still it will not happen. This is the law of nature. If we are to bring out heat from a colder system, we have to spend mechanical energy. So the main theme of the second law of thermodynamics is under which condition how many energy will be transferred to which direction. So from second law of thermodynamics, we came to know that for converting heat into other form of energy, heat engine should be required. So now I will explain heat engine. Heat engine, the device which converts heat energy into mechanical energy, is called heat engine. Look here, I have taken some gaseous substance in a container, and a tightly fitted piston is over there. Look, when heat is supplied to the system, then the gas expands. As a result, the piston goes upward. So if I keep some cotton or jute fiber on this piston, then the cotton or jute fiber will be compressed when the piston goes upward direction. So in this way, that if I consider it as engine, then it does work. That is, the engine absorbs heat from a source of higher temperature body and converts a part of it into work and rejects the remaining part of the heat to a sink of lower temperature, and the initial condition is restored. So an engine has three steps. That is, there should be a heat source which is at temperature T1, a system, that means working system, and heat sink. To get continuous supply of work from an engine, the cycle of operations are to be repeated. Since the cycle of operation can be repeated indefinitely, therefore the heat engine gives a continuous supply of work indefinitely. So let's look here. Let a working substance such as a gas in a cylinder, look here, I have taken some gas in a cylinder fitted with a piston, absorbs Q1 amount of heat. Here, this cylinder containing gas is the system. So this system absorbs Q1 amount of heat from the heat source. Q1 amount of heat from a heat source of higher temperature T1. The engine attains the temperature of the source during converting a part of heat into work. That means here the system attains the temperature of the heat source, that is T1. The engine attains the temperature of the source during converting a part of heat into work. Now to get work from the engine, that means to convert heat energy into mechanical energy, a part of heat absorbed from the source is to be rejected to the heat sink. It is heat sink which is at lower temperature, that is T2. So the heat which is absorbed by the system, a part of that heat is rejected to the heat sink. To convert heat energy into mechanical energy, a part of heat absorbed from the source is to be rejected to the heat sink at the lower temperature, so that the temperature of the working system, working substance is lowered to absorb heat from the heat source again. Okay. So if Q2 amount of heat is rejected to the heat sink at lower temperature T2, the amount of work will be what? W. Here W equal to Q1 minus Q2, because the system absorbs Q1 amount of heat and then it does work. Okay, and then it rejects Q2 amount of heat. So here W will be Q1 minus Q2. So from the conservation of energy, we can write what? We can write heat absorbed equal to Q1 equal to Q2 plus W. Here Q1 is the input and output is Q2 plus W. Okay, and we know from the conservation of energy, input energy equal to output energy. That means in conservation of energy tells us that there is no dissipation of energy. Energy is only converted from one form to another. So I can write Q1 equal to Q2 plus W. So from here, so the work done by the engine equal to W equal to Q1 minus Q2. Efficiency of the engine. Efficiency is termed by eta. This symbol which is looking like n, small n, it is named as eta. So eta equal to, output by input, W by Q1, but W equal to Q1 minus Q2 by Q1. So we can write Q1 by Q1 equal to 1 minus Q2 by Q1. So this is the efficiency formula of an engine, where Q1 is the heat received from the heat source, Q2 is the heat rejected to the heat sink, and W equal to work done by the engine. So you can see the steps of engine, and eta is the efficiency of the engine. So you have to remember one thing, efficiency is calculated in terms of percentage. Now I will explain reversible and irreversible process. Before explaining Carnot cycle, it is very much important to know reversible and irreversible process, about reversible and irreversible process. So reversible process is what? Reversible process, it is the process which can be retraced in the opposite direction so that the system and the surroundings pass through exactly the same state at each stage as in direct process. So look here, water cooling or freezing converts into ice, and ice on heating or melting converts into water. So this is a reversible process. Look, ice turns into liquid and liquid turns into ice. It is a reversible process. But look at this picture. Here, the egg after heating converts into egg marmalade, but that marmalade cannot be turned into egg. So it is an irreversible process, and most of the process, the thermodynamic change, or most of the changes in the environment are irreversible. There is a video which can make you more clear about irreversible process. So let's enjoy it. Irreversible process. A process that cannot be retraced back in opposite direction is called an irreversible process. In the irreversible process, the system does not pass through the same intermediate states as in direct process, even if the same initial state is reached. During this process, the system may undergo several intermediate states of equilibrium. If this process is made to produce in reverse direction, the system does not pass through the same intermediate state as in direct process. In the process of rubbing out hands, heat is produced, increasing the temperature of the hands. The mechanical work done against friction is converted into heat. But in the reverse process, we cannot make the hands to move in the same way on heating them. Consider a process of mixing up two gases which do not react with each other. The two gases exist in two different equilibrium states. In the process of mixing them at constant temperature in a cylinder, the mixture attains a new state in thermodynamic equilibrium. The pressure of the mixture is greater than the individual pressure and possesses same volume. In the reverse direction, the gases cannot be separated to their initial condition by decreasing the pressure. There is a comparative discussion between reversible and irreversible process. So let's try to understand. It is a slow process going through a series of smaller stages without each stage maintaining equilibrium between the system and surroundings. And in this process, the system attains final state from the initial state with a measurable speed. During the transformation, there is no equilibrium maintained between the system and surroundings. A reversible process can be made to proceed in forward or backward direction. Irreversible process can take place in one direction only. The driving force for the reversible process is small since the process proceeds in smaller steps. There is a definite driving force required for the progress of the irreversible process. Work done in a reversible process is greater than the corresponding work done in irreversible process. Work done in a irreversible process is always lower than the same kind of work done in a reversible process. A reversible process can be brought back to the initial state without making a change in the adjacent surroundings. An irreversible process cannot be brought back to the initial state without making a change in the surrounding. Dear students, this type of question frequently comes in the exam as your B number question, that is make comparison between reversible and irreversible process. So in that case you can write any of the 2 or 3 characteristics to explain it. Now I will explain Carnot engine. Carnot engine. Sadi Carnot conceived an ideal engine to convert heat energy to mechanical energy, which is free from all imperfections of an actual engine, is known as Carnot engine. So, in this engine, there is a heat source of temperature T1 where temperature will not be decreased if heat is taken out. Working object. Work will be done without any loss. Insulated platform, which is made by insulating material. Heat sink, which is at temperature T2. Temperature will not increase though heat is absorbed. That means in case of heat source, heat is given but temperature will not be decreased. And in heat sink, heat will be absorbed but temperature will not be increased. And working substance or working object is that where work will be done without any loss. So now look how Carnot engine works. So look here, heat source, heat insulating platform and heat sink. So a cylinder C with perfectly non-conducting walls and a perfectly conducting bottom. These walls are non-conducting but the bottom is conducting. It is fitted with a tightly, perfectly non-conducting and frictionless piston. An ideal gas is enclosed in the cylinder which acts as the working substance. The heat source is a hot object with very high thermal capacity. Capacity is maintained at temperature T1. Any amount of heat can be taken out from it without changing its temperature. At first I have told you that heat can be taken out from it but the temperature will not be changed. The sink is a cold object with very high thermal capacity is maintained at a lower temperature T2. Any amount of heat can be rejected to it without changing its temperature. That means its temperature will not be increased. A platform, it is made completely insulating object on which the cylinder is placed. Now I will explain the steps In 4 steps it works. This Carnot engine works. So I will explain those 4 steps now. Step 1. A cylinder, I've told you a cylinder C should be taken. So this cylinder at first placed on the source, and within a very short period the gas attains the temperature of the source. Let at this stage the pressure and volume are represented by P1 and V1. So now the ideal gas is enclosed to expand isothermally, and at the end of the process its pressure and volume becomes P2 and V2. Look here, initially the pressure and volume of the enclosed gas was P1 V1, and when it expands isothermally, and you know isothermally means where temperature remains constant, but it is not actually possible, because you know when any substance absorb heat, then its temperature should be increased. But Carnot thinks that here the gas expands isothermally where temperature remains constant. So when it is expanded isothermally, and at the end of this process the pressure and volume of the gas becomes P2 and V2, but temperature is T1. Initially its temperature was T1, and finally also T1, because temperature should be constant in isothermal process, and it absorbs Q1 amount of heat when the system is placed on the heat source. Step 2. Now the cylinder is placed on the insulating platform. Look here in this animation, at first on heat source, then insulating platform, then on the heat sink. So when the cylinder is placed on the insulating platform and the enclosed gas is expand adiabatically. Insulating platform, and you know the bottom is made in such a way that is perfectly non-conducting. So when the system is placed on the insulating platform, then it will not absorb any heat. So we can consider that as adiabatic process. Okay. So when the cylinder is placed on the insulating platform, the enclosed gas is allowed to expand adiabatically. That means in this position, the gas will be expanded adiabatically. At the end of the process, the pressure and volume of the gas becomes P3 V3, and temperature becomes T2. Temperature, because you know in adiabatic process, though heat is not absorbed, but temperature changes. Temperature will not remain constant. So temperature will be changed. From T1 it will be T2. Due to adiabatic expansion, the temperature of the gas reduces to T2, which is equal to the temperature of the heat sink. So here this curve shows adiabatic expansion of the gas. Step 3. So from this animation you can see, you have seen at first the cylinder on the source, then on the insulating platform, then on the sink. Now placing the cylinder on the sink, if we increase the pressure, then work will be done on the gas by the piston. As a result, the internal energy of the gas will be increased, but the enclosed gas rejects the increased internal energy as heat, keeping the temperature unchanged at T2. At this stage, the pressure and volume of the enclosed gas becomes P4 and V4 respectively, which is indicated by the point, by this point. At this point, the pressure and volume will be P4 and V4, but the temperature will remain constant. Here again it is a isothermal process, but here the gas will be contracted in isothermally. So it is isothermal contraction. So at first this curve is isothermal expansion, then adiabatic expansion, but again this is isothermal contraction, and then it will be again adiabatic contraction. So here at this point, if we consider this point is A, B, C, D, so at the point D, the pressure of the gas becomes P4, volume of the gas becomes V4, and temperature remains constant, that is T2, and the system rejects Q2 amount of heat to the heat sink. Step 4. At this step, the cylinder is again put on the insulating platform on this. Okay, so source to insulating platform, then sink, then again on the insulating platform. So at this step, the cylinder is again put on the insulating platform, and the pressure on the of the enclosed gas is increased adiabatically. As a result, its volume is decreased, because you know, if pressure is increased, then volume will be decreased, because it follows Boyle's law. Volume will be the decrease. As the volume is decreased, the temperature of the enclosed gas is increased and becomes equal to the temperature of the temperature T1 of the source due to work done on the gas. At this stage, the pressure and volume of the gas again becomes P1, V1 respectively, which is indicated by the point A. That is, the enclosed gas returned to its initial state. Look here, from the point A, the journey starts. Then A to B, isothermal expansion. Then B to C, adiabatic expansion. Then C to D, isothermal contraction, and D to A, adiabatic contraction. So again it will reback to its initial state. So we are seeing here a reversible process. That means a Carnot engine is that engine which maintains reversible process. So this is all about the Carnot cycle. You must try to understand it by practicing this graph, and try to understand it by your heart. Try to understand, try to make your concept clear by reading it for a repeated time. Then it will be more clear to you. Now there is a video for you which will make you more clear about
position. Also, it uses ideal gas as its working medium. And note that this is a perfect engine. No friction in between piston and cylinder walls, and no heat transfer between the surroundings and your system is considered. Now let's discuss how this interesting cycle works by exploring its processes of more reversible processes. So now for the first process, process 1 to 2. This process is called isothermal expansion. Isothermal in thermodynamics means no change in temperature. In other words, temperature is constant or unchanging within this process. So what happens here is that the heat energy from the heat source is transferred into the ideal gas. As a result, the gas expands, which then increases the volume and decreases the pressure. And next, process 2 to 3, which is called an adiabatic expansion. Adiabatic in thermodynamics means that there is no heat transfer between surroundings and the system, but the simply one change in temperature this process, our volume decreases and pressure increases. Third process is the isothermal compression. So by compression, it means volume is decreased and as a result, pressure increases. In this process, energy from the gas is transferred into the heat sink. And finally, the last process. The last process is called the intermittent compression. Since it's an intermittent, no change in temperature is contained in the system. Entropy is zero. Since this is compression, it means our volume decreases while our pressure increases. So that's it. That makes it a cycle.
So dear students, I think today's content is clear to you. This is a little bit larger content today I made, but I made it larger because I have to finish your syllabus very quickly of your year final examination. Sorry, for your half yearly examination. That's why I made it little bit larger. So try to watch my content very attentively. I think it will make you clear, and if any problem, then you will consult with me. Thank you everybody. Goodbye.